So, what is the current state of the Cosmos SDK as of right now?
All right, I'm going to be honest. I don't know if that's a good thing or a bad thing.
Go for it.
But the Cosmos SDK,
The Cosmos SDK is well loved and adopted, but its tech, architecture, and branding are starting to show its age and bring up problems. So this conversation is with Marko from Binary Builders around the current state of the Cosmos SDK, its tech debt and issues, which are all going to be solved in the major refactor of the new and improved Cosmos SDK. So let's get to it. Okay, so I'm here with the unofficial CTO of Cosmos, Marko. And so let's just talk about the Cosmos SDK. So what is the current state of the Cosmos SDK as of right now?
all right, I'm going to be honest. I don't know if that's a good thing or a bad thing.
Go for it.
But the Cosmos SDK is like we all know, a framework to build blockchains. And what it does really well is it allows people to build custom modules. And it's not really like a SDK as we know it in the software world, a software development kit. It's more of a framework. It kind of tells you how you're supposed to do stuff. And so it's been really good. It's been widely adopted. IBC is a first-class citizen within the Cosmos SDK via its modules. We use Comet, one of the most used consensus layers. It's useful. And when I talk to more and more users, it is kind of the de facto SDK for a lot of things that people want to build, not only because of how it's built, but also because of the history. It's in production, it's battle tested. And so it does have a lot of history, and people do like that. There are a lot of shortcomings, and that we're currently trying to taper, trying to control. And some of them really stem from back when the Cosmos Hub was launching. It was, we need to launch the Cosmos Hub. And then we're going to get to a bunch of this like tech debt after the Cosmos Hub launch because we just need to launch right away. And so it launched. And then as we all know, like Gore 2020 happened. So we had a huge amount of organizational chaos. Cosmos almost failed. A lot of companies, some VCs that I still run into today are still astonished that we crawled back from the depths of dead projects, just because everyone wrote us off in 2020 because of everything that was going on at the ICF. All the developers were leaving AIB. A lot of people did not know where the software was going to go, nor where the developers were going to go, and rightfully so. Not many people wanted to come and use Cosmos. Cosmos kind of got tainted with this image, and we crawled back. And so now a lot of the premise of what we're working on and a lot of the 2024 roadmap that we proposed in 2023, I know a lot of people were asking me, why are you doing this? Why are you doing that? It's on the premise of we're achieving what we're supposed to achieve 4 years ago, finally, and then we're able to move forward. And so a lot of the future work that we're doing is actually more exciting than where the Cosmos SDK is today.
So there's all this tech debt, but the Cosmos SDK is still the number one framework for building blockchains, and number two is not even comparable. If the Cosmos SDK has a lot of these shortcomings, why is it still the most popular framework out there?
For sovereignty, for true sovereignty as we know today, it's kind of the only option. We've had teams. I myself, my wife, I used to work at Polkadot. I've built Substrate chains. Back then, it was only Substrate in the Cosmos SDK, and I've talked to teams who were building with the Cosmos, who were building with Substrate, and they were deciding which one to go with. We had a lot of teams go with the Cosmos SDK, and some teams went with Substrate. And sometimes when I talk to those users today, of course, it's less so about the software, but about the ecosystem growth and features that either ecosystem has. They don't want to openly admit it, but sometimes they kind of wish they were able to join Cosmos or have entrance into Cosmos via IBC in some fashion. And so even today, we're seeing a resurgence of new users come to the Cosmos SDK. We're seeing the rollup world isn't the biggest right now, I would say. We're actually seeing a huge influx of AVSs. And this is entirely because there isn't really an alternative sovereign stack that allows you to have a decentralized set operating your chain. Everything is centralized sequencers, or if you're using the software, you have to use it in that ecosystem because of the permission restrictions of the license. So the Cosmos SDK is one of, if not the only, truly open source frameworks to build a blockchain with.
And so what was like the original sort of structure of the Cosmos SDK back in, 2020? How was it initially designed for like this like rigid app chain thesis of like these Cosmos chains with IBC? And then how was that like changed and modularized where like now there used to be like this rigid IBC vision of like app chains, and now it's more of a less like any piece that's valuable, you just like take it out of the Cosmos SDK, out of the interchain stack, and like shove it in your sequencer and your AVS. Like, how did it go from the original rigid app chain thesis to like what it is going to be in the future?
Back in 2019, everyone was forking something. Everyone was forking some software. And the original developers of the Cosmos SDK were like, we're building this for the Cosmos Hub, but since everyone's forking different pieces of software, why don't we just build an SDK? And the premise was that it was meant to be modular. Like it has this root multi-store. So it's like every module has its own tree, its own commitment structure. And you could replace individual commitment structures. You could replace how storage works. You could replace the underlying consensus engine. You could replace all the modules. You could replace how transactions work. It was all meant to be there. But at a certain point, it became, we need to ship the hub, we need to ship faster, and all these interfaces that were meant to be separate boundaries began to leak. And so everything began to leak, all the implementations were imported everywhere. It was one mono repo that when users wanted to modify, it became harder and harder to do. Some users, like some of these features were like users don't even know about because it's just so hard to do that if we were to try and do it ourselves, it would probably be at least 2 to 3 months of us trying to figure out how to do it because of how the SDK was designed and how it was like needed to ship. Now, with everyone coming, we have like some specific partners with who are using and will be using our V2 from day one. The likes of Barachain, we're working with the Omni team, we're working with Osmosis, and even with Strangelove on their new implementation of consensus called Gordian. And so it's already like a testament that a lot of these users just want to use the middleware. They went and designed a blockchain, let's say the EVM just on top of Comet. And it's like POC works, the MVP works. Now becomes the hard part of all of this extra tooling around that is the things you need to build. And then they go look at the SDK and they're like, that has everything I need. Why don't I actually just put that in between the EVM and Comet? And so it's more so becoming a middleware. It's becoming an execution middleware where users don't have to use modules. Users don't have to use the native runtime, we're going to start calling it. They can essentially just say, we just want storage. We just want the functionality of pruning, snapshotting, talking to consensus, this extra APIs, and all that. And then we just don't want to use the modules. We want to create whatever we want. And so we're going in that direction. But in going in that direction, it's, okay, now if you want to replace the storage with a custom storage design, instead of having to fork the SDK, modify all the code, it's you replace a single component. And so it's really broken up into roughly 3 layers in the new design. You have your consensus, and that consensus is, for our default, will be Comet BFT. We're working with Strangelove to implement Gordian. There's Rollkit. We've been talking to Polymer with their OP stack sequencer to be on the bottom. So it's already becoming replaceable. And since that layer doesn't assume ABCI, doesn't assume really any API, it's like it only assumes the APIs above it that you want to communicate down to consensus, then you can really use anything you want. And then once you go a layer up, there's this app manager. And the app manager has a direct connection to storage. And that storage is any design you want. For us, we have a separation between storage and commitment. And so when we look at a blockchain, and when we really ask ourselves, like, what does a blockchain actually care about? It actually doesn't care about light client proofs. It doesn't care about Merkle trees. It doesn't care about a commitment structure. It just, because it itself can calculate an app hash in some way. You can, if you don't care about light clients, you can use the DB checksum. But it just, when it's doing a get and a set, all it does, it needs to do a get from a raw database, and then it does a set into the commitment structure and the database itself. So yes, it is two writes, but what is written into the commitment structure could be a lot different. You could have your commitment structure be constant in size, meaning that it won't ever grow because of how you're building it. And so in this design, like, the storage becomes as fast as a database. Like, there's been millions of dollars spent on building databases. Why should we try and recreate it? Why should we try and recreate the wheel? And this is something that goes into the aura of, or into the ethos of blockchain. It's like we keep trying to rebuild the wheel, but it's like there's so much technology out there that's millions of dollars have been spent. Why don't we just go use it, and we can optimize that, because they're going at speeds a lot faster than a blockchain can go right now. So why do we have to like recreate the wheel? And so that's the storage layer. And so in the storage layer, you can replace it, you can put something else in there, or you can really do whatever you want. And that's the app manager. And then above the app manager, we have this thing we're calling STF, and that's the state transition function. And in the state transition function, the cool thing it does is it takes a transaction or a state transition, and it executes it against the module or the EVM or some virtual machine, anything you want. Now, when you want to prove execution in terms of, let's say, in this rollup world, when you're doing fraud proofs or validity proofs, you need a form of like proving node. And in that proving node, you essentially want access to a database that has the pre-state and the pre-app hash state root and the post, and then you get the state transition, and it has all the state needed to conduct that state transition. And then proving node will execute that state transition. If the output is the same as the expected output, then it's true. And so in this sense, the Cosmos SDK is entirely becoming decoupled. It's becoming that you can take components, not because before it was everything in one. And so if you wanted to take a component, like if you wanted to run modules in a ZK VM, you had to take this whole thing. And when we were talking to users and people were starting to be like, oh, we want to prove, we want to run faster, we want to run leaner, then it was like, okay, like this big components, let's split into 3 components and let's make them as slim as possible in order to reuse them in constrained environments that were not being thought of before.
Mm-hmm. And so I guess let's just go, from top down, all of the changes being done. So you're talking about you said state transition function. What was it again?
Yes.
At the top.
STF. Yeah.
STF. On these modules and the different execution environments, and how it used to be very rigid on like sort of the modules, and now it's sort of just like any execution environment, any modules. And we're also seeing like some people go like, we don't want to use any modules, but we want to like use, Rust smart contracts or Go or just whatever language. And so what are some just recent changes or improvements with that stack? Is there any like experimentations you see going on?
Yeah. So, right now we're getting so in terms of users, there's 2 users that are kind of like in the boat of, we just want to use the middleware. We don't care about anything above, and we want to use it without the modules. And with those users, we're working with, and we're kind of like identifying issues in the old stack and making sure they're cleaned up in the new stack. The interesting part becomes like how you can swap things out. And so all of a sudden it becomes, okay, I need to update everyone in the network to get this change to, I can modify my node with this like experimental thing. And some of the experiments that we're doing, we haven't started because we want to get like this V2 working. We want to get it out the door. So we have a chain running with it. We've started to send transactions through. Every so often the transaction halts the chain, but that's like, okay, like we found where we're missing something. And so we're running tests, we're running the simulator, and just making sure it all works in accordance to what people are expecting from the old stack. And so modules don't really change. The thing we want to do, and we're doing around this work, is decreasing the dependency graph. And so by decreasing the dependency graph, we're working with risk zero actually to prove modules within their ZK VM. So it's like, how do we take modules and how do we create like a simple proving node with this new structure, and then how do we give it to a ZK VM to actually prove the execution? And so that's kind of like the biggest experimentation that we're doing. It's not like crazy exciting, but the other experiments that we want to do are along the lines of, we want to really like start to question a lot of the things we're taking for granted because early blockchain like kind of just did it. And I think Solana did a really good example of this, where they're like Merkle commitments, like we don't have to do it every block. We can do it like every n blocks, like every epoch or something like that. Storage, like historical storage, like do you actually need it? Do you actually need like 3 years old state? Like it's questionable. And they kind of like started that. They started rolling the ball down the hill of, are the things that we're taking for granted actually things that users care about? And so we're starting to actually ask those questions as well. Like some chains may not care about light clients. They may not care about using IBC. So it's like, if they're not caring, then why do they need a commitment? They can potentially use something as simple as like a DB checksum that comes natively out of databases. And so by like really honing in on the things we take for granted and understand today, the things that everyone wants, or because I think, let's say 70% of them were correct. That 30% everyone's just kind of doing just because it was what the original people did. And very few people are actually questioning, like, do we need this? Do users need this? And by questioning that, I think we're able to unlock a lot more performance and unlock a lot more users that maybe are using a blockchain but don't really care about some of the aspects that we may care about by being here for since the early days.
Yeah, and that brings on another question. What are you guys going to do with IBC? You're just going to keep it as a module, or do you plan to lower it deeper into the stack? Or where does IBC go?
There's multiple approaches. So we developed this new accounts module, and the accounts module was built on the premise of both account abstraction and authentication abstraction. And so you can use any form of authentication, email, password, really anything to sign a transaction, anything that you feel is secure. And in those modules, it kind of created its own capability system that the module can't really access stuff outside. It needs to like make queries or make transactions to access the things outside. And in talking with the IBC team, they were also thinking, okay, like now since you have this, like technically IBC could just be an account. And it's like we're like toying with the idea of it. And then that would kind of make it a lot easier to launch with. So right now it's like you have this like huge app.go file, and in that app.go file you have to like define a bunch of lines of code, and then you have to understand what's going on. Then it's super hard. You end up copy pasting code from others. And so now it's like, oh, can I just like in one line just add different features of IBC? And so in doing so, I mean, the other part is we can make IBC like a more of a first-class citizen, like more natively integrated. But interestingly enough, we're starting to run into users that are using the software and like don't really, like they're not worried, they're not thinking about IBC at all. They're just using it because it's a piece of software that they can build the application with quickly in a matter of months to get a chain deployed. And so there's like, and when we talk to them, we're like, hey, what about the IBC? They're like, oh, like we'll think about that in like our V2 or something. It's not a concern for launch. While yes, a majority are thinking, yes, we want the IBC. That's like a big reason why we're using the Cosmos SDK. So it's kind of like a hard thing to answer. If we want to go into the true like computer science SDK, and like we are a library, like we don't make the decisions for you, then making something as IBC, as like this application specific thing, ingrained in the framework, it starts pushing us more back into the framework instead of like the library. So the library is kind of like, you have all these components, they should be easily instantiated, created, and then you can use it. But if we say, okay, like you can use it, but IBC is mandatory for everyone, then it's more of a framework. Then we're kind of telling the user what they're supposed to be doing.
Okay, so I think we covered the top half, and I think you also covered the middle half of just like, the storage, and you can just use whatever database you want. Also, like how Solana doesn't have any Merkleization, and
it has Merkleization, but like delayed.
Okay.
Yeah.
Or they don't have. It's like the light clients. Yeah. That was the whole deal.
Yeah.
Another thing was, so now let's talk about the bottom half on just what was it, consensus? Or now we're starting to like defer consensus to like things that are not Comet BFT. Let's just like go through the consensus protocols and all of the like things you get to swap out for consensus.
Yeah. I mean, so I did work on Comet for 2-3 years. It will be my like baby forever and always, no matter what happens to it. And they say don't get married to the software, but I think with Comet, I definitely got married to it. But the Comet team is working to modularize their stack in the same way like we're doing ours. We're taking just a different approach. We're taking a much more radical approach, and they want to do like piecemeal. Like we want to modularize this piece, we want to modularize this piece, and we're just saying like, fuck it. Like that's going to be like 2 years of work. Sorry, I don't know.
I don't care. So,
okay. We're just saying like, okay, like we don't care if like that's going to take a long time to do that, like piecemeal, piece by piece by piece. We're just going to rip it out and just say this is the new thing, and that's what like we're doing with V2. The goal is not to use any of the old software at the core level. The modules will stay the same, but not to use any of the pieces of core and just rewrite that. And so Comet is like, it was more so designed as a library than the Cosmos SDK, but it fell into the same pattern. So if we go look at the history of Tendermint used to be, I think, like 8 or 9 repos. So it was modular. It was meant to be a library that you combined. And then it was, oh shit, we need to ship mainnet for the Cosmos Hub. So let's bring it all into the same repo. And then after mainnet, let's disperse it back and like make it modular. Of course, organizational chaos, that never happened. So it was all there. We were so close. So at the Comet level, they are like modularizing consensus that you can swap out to different consensus algorithms. The interesting thing is that, okay, so we allow people at the SDK level to use Gordian from Strangelove. They're using ABCI. Rollkit that also uses ABCI, but they want to modify ABCI for their specific use case. So right now they can't do it unless they fork Comet and then maintain that and then maintain a fork of the SDK. And so by like bringing this into like its own package, then Rollkit can write its own consensus package for the SDK, and then they can customize it freely. Same with Gordian. The Polymer OP-Stack SDK stuff was just announced by Nethermind, and so we were talking with them a bit to see how that would work and like what is the API needed, just as a test to see if it's possible, like our goals are possible. And yeah, so it is coming there. It's like it's free to, not only is it like you can replace consensus, but if you want to change stuff about how consensus is working today. So if you wanted to go from execution to optimistic execution to immediate execution, this could be like 3 different packages. And if a chain wanted to use one, they just use it and it's using Comet. All 3 could be using Comet. And instead of doing like feature flags, then you need to start configuring like all this and that. It's like, oh, like we can make it modular that you can plug in the execution model, because everything above consensus does not assume the execution model. It just assumes that, okay, you give me transactions, you tell me if I can execute it. If I execute it, I will return you a hash. But other than that, it doesn't care about anything else. The whole execution model, if it's like immediate finality, delayed finality, all this stuff is on the premise of the consensus layer or the consensus package.
I think that was good. Now let's just talk about the whole stack as a as a whole, there are these talks around just like doing it in Rust, as they always argue about. What's your opinion on that? Do you guys want to Rustify everything, or yeah, just tell me about that.
I at one point I was like, oh, like what would it look like to rewrite it in Rust, and like the core layer, and like we kind of have the uphill battle of everyone is using Go modules, and to call from Rust into Go is a bit dangerous. Like memory calling from a language that doesn't have a garbage collector into a language that has a garbage collector could be iffy. There's ways to get around it that you can do, but it's not. So I was thinking about this a lot, and I came to the conclusion that it's not necessarily the language that's the issue, and it's not necessarily like the core. Like a good example is like Hyper SDK from Avalanche. Like they have an amazingly performant piece of software, and it's written in Golang. But then it's like above that, you can write it in whatever you want. You can write your modules in Rust. You can pull in a VM. You can do whatever you want. And so it's like, we want to allow users to write modules in Rust. And so that is like on our 2024 agenda. And we have been doing research on it, just to like how to design it. We've been talking with the Sovereign SDK crew, with Cosmos on like, okay, are we just bringing Cosmos contracts to native Rust? Are we going to use Sovereign? Like, what is the idea? What's the premise here? But like the core doesn't necessarily have to be in Rust. Like we can make it as performant. Of course, it's like you need to jump through some hoops, but it's like the core has less to do with if it's in Rust or I don't know, C or something else. Like, of course, you can make it faster, but Go's already pretty performant, and it has a really good distributed systems background, has a lot of like good libraries. So at the core level, it's just kind of like, what would we actually gain?
Mm-hmm. Yeah, I've also heard that like Go is better for more distributed systems, although I hear that's also changing, or what's your opinion on that?
Well, so my matters who you ask, because I might ruffle some feathers now. But I'm at the Anoma retreat, and they were writing their whole like consensus layer and P2P system in Rust. And at a certain point, they're like, this stuff, it's so hard to do this in Rust. Was their conclusion, and they kept running into bottlenecks. They kept running into issues, and they're really experienced engineers as a whole. While I think Rust is really good, it does have some shortcomings, and some of the shortcomings are like, the nice thing in Go is there's not a million ways to do one thing. Usually there's maybe like 2 or 3 ways to do one thing, and maybe in some cases 1 way to do one thing. And then it's like, if you want to get fancy, you could like turn off the garbage collector, manage your own memory, and do all this stuff yourself. But that's like kind of like outside the scope of Go. This is like the unsafe part. In Rust, there's like a ton of ways to do a ton of ways to do one thing, and so it's like, it becomes harder and harder to like reason on what you're doing, what design you're using, and everything like this. And so the Noma team decided to write their P2P and consensus, the distributed system part of the stack, in a different language. So they like wrote most of it in Rust. They were like almost done, and they kept running into issues, into bottlenecks, and they said, okay, we're going to rewrite it in something else. And so they ended up rewriting in something that's not Rust, that's not Go. If you know the language Elixir, Elixir is based on Erlang. It is Erlang and Elixir, less so about Elixir, but Erlang is the language that powers the world. It is like in our satellites, it is in our telecommunications. Some of the most scalable systems were written in Erlang. And so WhatsApp was written in Erlang, and that's like a large reason Facebook bought them. And so it is a question like, is it worth writing it in Rust if the people who are like trying to push the boundary as hard as possible are already rewriting it in something else? And it's kind of goes back into like the core thing. It's like every language can be made fast. Like you can write it in JavaScript, you can write it in Deno, you can write it in all these things, and it'll be fast. But you can write it in like, I don't know, Python would be slow, but like you can write it in Elixir, you can write it in Go, you can write it in C, you can write it like in JavaScript, you can write it in all these different languages, Ruby, and make it fast. But like I don't think it's like necessarily like, oh, we're going to rewrite everything to Rust because the blockchain ecosystem loves Rust and that's like the way to go. It's more so, okay, we should actually make technical decisions based on what we know, what other people have done, and based on our needs.
Mm-hmm. Yeah, I've heard that like Go is for distributed systems, and like the core engineers use that, and then like Rust is for like all the fun application stuff because like they love experimenting. But like the distributed systems people don't like headaches and don't like doing anything crazy like that. Another thing, and we mentioned like all these languages. Yes or no question: will Cosmos ever get into client diversity or anything like that? I'll tell you, I don't think. I think it's useless. I think just like
okay. I agree. Like the premise of multiple clients are needed for like true decentralization, because if there's a bug in one, it's like everything goes down. I don't know. It's like, AWS is probably written in one language, and probably different backends are written in one language. And if it goes down, like there's systems to like recover it. There's like systems to like put it back into the old release and everything like that. I think like Ethereum went on the extreme version. Like Bitcoin is simple enough that it's like, if you want to write a Bitcoin client, like you can write it fairly quickly. And the maintenance overhead is probably not that high. It's just like the adoption curve. Ethereum went with like, there needs to be like 8 clients. I think there are 8 clients, but then all of a sudden like, okay, it's cool for a couple of years, but like it becomes a huge cost to the chain. Like now all of a sudden, how is the team supposed to survive? Like consulting services, like what is the future? And so so it's like I don't think it's really needed that much.
Yeah, I just wanted to get that out of the way. I also think it's a money pit, and like I guess, but like has there been any like central retaking of programming languages that you can't like go back to an older version and like fork? Or I don't know. I think it's
no. Yeah, I mean, this is like, it was funny. I was interviewing someone and he's like, like you guys code in Rust and Go. Those are like super new languages. And I was like, what do you use? And he's like, I only write in Java. And I'm like, okay. Like, and at the end of the day, it's like Rust is being adopted by Google. It is being adopted by all these like large companies for its memory management and stuff, which is like super good. But like Go is kind of entering into the like Java-esque world where it's like all the blockchain people are like, I don't really like want to write Go because it's like this weird language, blah, blah. I want to write Rust. But it's like when we go talk to enterprises, it's like a lot easier to like tell them to like use Go than it is to use something newer. And then also the onboarding to something like Go is a lot faster. So like writing Rust, like I've written smart contracts on Cosmos, I've done hackathons on Solana and different ecosystems. It's like there is an overhead that's like kind of hard to figure out to learn Rust. And it's like I feel like I'm pretty proficient, and it's like when I go and read code, I can understand it. My eyes are used to it. But it definitely took me like 6 months to like be able to do that. And I was like coding to like build an application in that time. And so it's like, is you need to sacrifice 6 months every time you hire someone to like get it? Because Rust engineers, like good ones, are hard to find.
Mm-hmm. Also, Go is also memory safe. I don't know why. Anyways, let's like end the language arguments. Now let's talk about like other frameworks that are or Cosmos projects that are Cosmos projects but don't use the Cosmos SDK. They use their own framework. I guess like the main 2 examples are Nomic, and then like the Anoma, Penumbra, Namada family.
Yeah.
So just talk about why didn't they use the Cosmos SDK, or any of the changes that they do going to be adopted by the Cosmos SDK?
So Nomic was more on the premise of like, we just want to build something because it's like, the Cosmos SDK isn't fast enough. We need more scale. And have yet to see like that scale hit their chain. And it's also just like such a large overhead. It's like when you're developing an application, I think Anoma and Namada are like perfect examples. It's like they went the path. Anoma makes sense. Namada, like when I talked to Chris, it's like if I was in his boat, I would have made the same decision because back when they made the call, the Cosmos SDK wasn't in a good place. The maintainers were like moving forward and doing good things, but it was like going in a direction that they didn't agree with, and so they weren't assured that like if they went with it, they would be able to work with it long term. And that's like a totally fine decision. And now it's like when I talk to Chris and I'm like, hey, like when are you guys coming back to the SDK? And he's like, oh, like it's funny because we were actually like talking about that recently. Like if the SDK was where it was today, then maybe Namato would have been on the Cosmos SDK instead of something else. In the Penumbra case, it's like they're building something entirely different, and I think it would be very hard to like build what they're doing in the Cosmos SDK, like privacy first. The whole chain, they like re-architected everything from the ground up. And so like in that case, it's like Henry is a genius. Like, so it's like, I do think it was better for him to do it than wait for us to do it just because we didn't have our shit together. But Anoma like definitely would not be able to like fall into the Cosmos SDK just because of the complexity and what it's trying to achieve. And so for that one, it totally makes sense to start from scratch. But for the Nomic, like, I don't know. I think they could have built it into the Cosmos SDK and like launched probably in half the time and probably with less overhead. With Namato, like maybe in 6 months I'll be able to say like, oh, Namato should just come to the SDK and try and convince them to do the migration. But for now, I think it was also the right decision.
Yeah. Also, historically, like Cosmos has been ahead when it comes to like distributed systems, proof of stake, frameworks. But like the thing that it missed out on a lot, I think overall in like the scaling architecture category is like ZK. And like that's where Ethereum really like that's where essentially all their scaling, that's where they're all going to. How does ZK interact with the Cosmos SDK? Is it just how's the future with ZK and the Cosmos?
Yeah, so there are different forms of ZK. So there is like proving with validity proofs, like the ZK VM stuff. There is like privacy in terms of like private state. And so in those two, it like we can have private state already today. It's just a matter of like we just need capacity to like code it out. And with the ZK accounts that Celestia has been researching with the working group and everything, there's been a lot of interesting stuff. Like Ethan Buckman did like a POC using the SDK, and that worked out well. And we were like, oh, like with the new accounts module, you can make it even cleaner. Like you can make it stateful instead of only stateless, and you can do a lot more interesting. You can essentially create like an on-chain scripting language via ZK VMs. And keep the state private, and the chain will like verify and then like execute stuff outside. So that's already like possible today. It's not like a first class citizen per se. It's not like, oh, the whole bank module will be private. That would take a lot more work. And then in terms of proving, like we are working with RIS0 to try and get a module, like a single module, down to work in the ZK VM. And in doing so, we're discovering where the issues are, and we're trying to patch the issues as they come up in order to better understand and get the software to a place where it is easier to use, easier to write, and easier to compile. So we are working in that direction. I remember, I want to say 2020, I think it was 2020 or 2019 when I started. And like ZK was like being talked about back then, or 2021, something around there. And when I was talking to Zaki, I was like, oh, shouldn't we like worked a lot closer with Zaki then, still work close with him. He's here, and Zug with me. And it was like, I was like, shouldn't we hire some researchers to do this? And he was like, let everyone else figure it out, and then we'll just come up and use it. And so it's like, and the figuring out actually took a lot longer than expected, because that was 2020, and now we're like 4 years in, and now we're having a huge jump. But it's like, if we hired researchers to do that, we would probably be in the same place. Like, look at the teams like Polygon, Plonky 2, Plonky 3, like they're doing a lot of good research. But when it's like using the technology, they're using like Succinct. I think there was just an announcement that they're going to use Succinct. Mm-hmm. And so it's like, would it have been beneficial for us to like get researchers and just research, and then anyway wait for someone else to do the implementation? And so that was kind of like when it hit me like, oh, like we shouldn't worry about this for now. But when it starts hitting acceleration, we need to be ready. And the problem is we weren't ready. Now we're working on getting ready and being there at the forefront with all the other frameworks. And if the year was 2023, because in 2024 we had this huge acceleration, if the year was 2023 and we were doing the work that we're doing today, then by the time the acceleration started, we would have kind of been there. We would have already been using it. And so we just weren't ready when it went parabolic is kind of like the short answer.
I think that's funny that he said that, because do you think other ecosystems say like wait until Cosmos builds it and like we'll just take their implementation?
I think it's like what I think goes on. It's not really like a direct, like no one says it that direct.
Yeah.
Like Zucky's kind of like no bullshit. Like he's going to say what he thinks. And so I don't think a lot of ecosystems think like that. I think probably what other ecosystems do is like they probably like Sam Hart is like a really good example. He participates in a lot of conversations, explaining stuff and whatnot, and he does a lot of research. And then it's like a few months later, you see ETH or some other chain come out with a variation of that, and you're just kind of like, oh, like this kind of started within the Cosmos. Like Sam, Ethan, like Celestia, like everyone like is doing stuff, and then sometimes it's like someone else does it and then it gets a bigger highlight, like it's covered by press and everything like this, and it's like Cosmos is kind of like in the background like, oh cool, like we're like on to the next thing. And it's like kind of happening. Like it's funny, I'm friends with Rob Habermeyer from Polkadot, and we do like catch up here and there, but they were talking about this DB stuff that they were like working on, this like new database for Substrate. And I was reading it and I was like, okay, cool. Like we were kind of thinking of like if we should go down that path or if we should go down a different path. We chose the different path just because it's simpler, in our opinion. But when we talked to them, like we worked with the Crypto.com team, they did like a M-mapped IVL tree that is like insanely performant. But they're doing it on the raw file storage of the operating system. They're not using an underlying database, so they kind of like built it. And when it was like comparing benchmarks, of course there's like different tree types. It was like, oh, like the mem IVL is actually faster than what they're working on. And it's like, oh, cool. Like, and when I was reading it, it was like super cool, like super novel. But for us, it was just kind of like, okay, we want a different approach, and we think our approach is like a lot simpler than having to like rewrite everything from scratch. And so it is like interesting, and people keep telling me that like, oh, we need to get out there, we need to like promote what we're working on. But it's also like, I think we will get there, but it's just like Cosmos isn't the people who market and then build. We build and then market, and it's not the right decision in crypto because everyone markets and then you go like I remember when some teams launched and I would go read their code. I'm like in Telegram, like, hey, where's this code that you announced? They're like, oh, we haven't built that yet. And it's like, wait, but what? Like, come on, guys, like you can't do this.
Is there anything else we wanted to talk about? Any announcements, changes to wrap things up?
Well, I'm in a dilemma right now, and it's like I'm trying to figure out what to do. And it has to do with the Cosmos SDK. It's nothing about the software, but it's about branding and kind of like the whole Cosmos interchain story of branding. But I'm hoping that we have an announcement there soon. And so I can't say too much more. But I mean, basically, like if you want to use the V2 stuff that we're building, reach out and let's get you on it. And let's get you testing on it so we can get the feedback. It is already a huge performance improvement over the last design. So everyone's going to get faster and everyone's going to get there for free. And Osmosis and the Informal team are doing an amazing job on performance improvements on Comet, and that stuff will also be there. And so it's going to be a whole new world, a new sovereignty.
Yeah, that sounds exciting. Anyways, insert whatever the podcasters say at the end. And thank you so much for coming on.
Cheers. Thanks for having me.
Thank you.